Hi everyone, today we're going to talk about North Carolina 7th grade math standard NS1, number systems. It states, apply and extend previous understandings of addition and subtraction to add and subtract rational numbers, using the properties of operations and describing real-world context using sums and differences. This video focuses on a strategy that will teach students to rewrite subtraction as addition and apply properties as needed. It will also teach students to apply their knowledge of addition and subtraction of rational numbers to describe real-world context, and in the process, develop their own rules to add and subtract rational numbers. Let's begin by looking at a hot air balloon. Conceptually, kids are familiar with balloons, and they understand that air makes the balloon go up when it's added and makes the balloon go down when it's taken away, and weights will pull the balloon down when they're added and make the balloon go up when they're taken away. Before you begin your lesson, it is critical that you define what adding a weight does to the balloon. First, kids must understand that a weight is like a -1. So if you're adding a weight, you're adding a -1. And in this instance, it will bring the balloon down 1 unit. If you're subtracting a weight, remember, a weight represents -1. So you're subtracting a -1, and in this case, it will take the balloon up 1 unit. Well, let's talk about puffs of air. If you're subtracting a puff of air, remember a puff of air represents a positive, so you're subtracting a +1, and in this case, it will bring the balloon down 1 unit. If you're adding a puff of air, it's like adding a +1, and that will bring the balloon up 1 unit. Once you've defined these 4 possibilities, it's great to start with a concrete example. Kids are familiar with the number line from 6th grade, so let's use the number line. Currently, you're 7 feet in the air and you add 5½ bags of weight. Note that the 7 represents the location of the top of the basket. By adding those 5½ bags of weight, kids will say, oh, it's going to go down. That is correct. The mathematical statement should be written as 7 plus a -5½. It is critical that you make kids write this statement so that you know they understand conceptually what's going on with the balloon. Then they can use the number line to see that their result will be 1½ feet. Now let's say you're 7 feet in the air and you throw out 5½ bags of weight. Again, you're looking at the top of the basket. We have those weights that we throw out. The kids should say, it's going to go up. That's absolutely correct. The balloon will go up. The mathematical statement should be 7 minus a -5½ because you started 7 feet and you're taking away 5½ weights. And the kids should see, again, using the number line, that you're at 12½ feet. Okay, let's say you're 7 feet in the air and you lose 5½ puffs of air. Now what happens to the balloon? The basket started at 7. Losing air will make the balloon go down. The mathematical statement would be 7 minus a +5½ because you started 7 feet and you took away 5½ puffs of air. And the kids should see you're at 1½ feet. Final situation. Let's say you're 7 feet in the air and you add 5½ puffs of air. Well, if you're 7 feet in the air and you add air, that should make the balloon go up. The mathematical statement should be 7 plus a +5½. And by using the number line, kids again will see that you're 12½ feet above the ground. Once you've given the kids these 4 different scenarios, it is important to identify which one ended in the same result. So I will begin by asking, there was a situation where we were 7 feet in the air and you took off 5½ weights, and you ended up 12½ feet in the air. Well, which situation ended with the same result but were under different circumstances? Kids should note, when you were 7 feet in the air and you added 5½ puffs of air, you also ended with 12½ feet. So since both of these situations have the same result, kids should recognize that subtracting a negative is the same as adding a positive. If kids do not recognize in these 4 examples this on their own, it is important that you allow them to have other opportunities by giving them more examples. A great way to do this is to give two different kids two different scenarios that end in the same result and allow them to post their answers on the board. So eventually kids will see the pattern that when you subtract a negative, it's the same as adding a positive. Let's look at the other situation and find the same result. I was 7 feet in the air and I added 5.5 weights. And it brought me down to 1.5 feet. The kids should immediately recognize that when they were 7 feet in the air and you lost 5.5 puffs of air, it also brought you down to 1.5 feet. Again, it is critical that kids understand these same results gives them a rule of adding a negative is the same as subtracting a positive. You do not explicitly state this, but you do want kids to see it. Let's move on to the abstract. The abstract is allowing kids to understand that their process and rules will help them when they deal with larger numbers. So I will begin by using a conceptual, concrete idea of having a balloon 100 feet under the ground. Yes, this is a fancy place. They have balloons under the ground. And they take away 2¾ weights. I would ask my students, what is the new height of the balloon? Now, we're not using a number line. We're going to use what we just learned and our process of changing subtraction to addition to answer this question. First, I let my kids write the mathematical statement. Negative 100 feet minus negative 2¾ Then I ask the question, well, what will happen to the balloon? Taking away weights makes the balloon go up. So then I also ask my kids, well, do you think it'll be above the ground or below the ground? They should note that since I'm taking away 2¾ I'm moving up 2¾ feet, which would move it above the ground. I would also ask my students, well, what's another situation that would give me the same result? And they should say, a hot air balloon is released 100 feet from under the ground, and you add 2¾ puffs of air. Then we again discuss, well, what's the height of the balloon? So the mathematical statement would now be negative 100 plus a positive 2¾ Kids will note again that it will move them up. They see again that subtracting a negative is the same as adding a positive. We have now rewritten subtraction as addition, and they can find the final answer to be 103¼ feet. Let's unpack these standards and look how they vertically progress from 6, 7, all the way up to 8th grade. When we look at the unpacking document, there's a part that clarifies that in 6th grade, students only dealt with integers, positive and negative whole numbers between negative 20 and 20, and they were using a number line. But in 7th grade, we are to expand this understanding to rational numbers. They will rewrite addition and subtraction, and they will develop a process, their own rules. It also gives you a way to check for understanding. So if you'll note, here's some scenarios or some problems that you can look at that will help you identify if kids truly understand what they should get from this standard. In 6th grade, students were applying their previous understandings of addition and subtraction, but they were talking about zero pairs. They were only using integers, and they were only going from negative 20 to 20. In 7th grade, we now extended to rational numbers, which are fractions, positive and negative whole numbers, numbers larger than negative 20, numbers below negative 20, numbers larger than positive 20, and they're also dealing with real-world context so that they can develop some rules. So to sum it up, vertically, in 6th grade, students learn about zero pairs. They learn about opposites. But in 7th grade, you extend that to rational numbers. Kids need to understand that negative 5.5 and positive 5.5 are also zero pairs. In 6th grade, students were using integers between negative 20 and 20. But in 7th grade, they will use rational numbers, which will include fractions, decimals, positive, negative whole numbers, all type of numbers, and it will extend beyond negative 20 and 20. In 6th grade, students were required to use the number line to understand conceptually adding and subtracting positive and negative integers. But in 7th grade, they now learn to rewrite subtraction as addition and apply the properties as needed. Finally, in 6th grade, students are not expected to know the integer rule. But in 7th grade, they will develop a process of their own rules. Now let's go from 7th grade to 8th grade. In 7th grade, students again were applying their knowledge of rational numbers by adding and subtracting in real-world context. Well, in 8th grade, they introduced irrational numbers. Students must have a good understanding of rational numbers and how to define them so that when they get to 8th grade, they can extend it to defining irrational numbers. Also, in 8th grade, students will solve equations where they will have both positive and negative integers, but they'll also have rational numbers. And they must also understand how to add and subtract rational numbers when solving equations. So let's conclude by me reminding you that this video was for 7th grade Math Standard NS1. Thank you.